Hello, and welcome to the video, Static Class State Management with Flutter on DartPad. This is part of the Learn Flutter Now series of videos on learnflutternow.com. My name is Chuck Bagby, and I'm a software development manager with Outsourced Coders. This video focuses on state management only. Other widget classes and layout are covered in separate videos and the online Flutter documentation. Let's get started with Static Class State Management with Flutter on DartPad. I will open the gist titled Static Class State Management from GitHub by clicking the link on the Learn Flutter Now website, or you can navigate to the link shown. Press the Run button to start the program. The top of the file is the root of where the application starts. I will scroll down to where the static class for state management is defined. This tutorial has a global static class instance and 3 screens. The use of a global static class instance is often referred to as the singleton design pattern. A static class or singleton will only be instantiated once during the running of the program. Additional attempts to instantiate a new class instance will result in returning a reference to the instance that was already created. The static class is defined at the beginning of the application. There are 3 steps to creating a static class in Dart. The static and final keywords are used to declare a class member variable that has an internal reference to the class. Typically, multiple instances of a class will each have their own independent variables with independent values. When a class member variable is declared as static, all instances share the same member variable and therefore the same values stored in the member variable. Prepending an underscore in front of the variable or method name will make the variable private and accessible only from within the class library. A named constructor is created with a prepended underscore so that it is only accessible from within the class library. Finally, a publicly accessible factory method is created that will manage the creation of the class. It will return the static member variable that contains a reference to the single instantiated class. The singleton class used in this example also includes a public counter method that will return the counter and a method to increment the internal counter variable. Please note that everything in this class that has internal underscores highlighted in red are private and not accessible from outside the class. The class factory, getCounter method, and incrementCounter method, which are highlighted in green, are publicly available from outside the class. Now I will scroll to the top of the file. The static class is instantiated at the root of the application. In other words, where it is instantiated is not contained within any curly braces. This makes the object instance available to the entire application. This is referred to as global scope, and why it is called a global static class instance. Using a global static class ensures that data stored in the instantiated class object is available everywhere in the application. So it will not matter which screen of the application you are on. You will always be able to access this data. The main function is also at the root of the application. So when the application starts, it instantiates the single instance of the global static class, then executes the main function and continues executing the code within the main function. The first screen is titled the A screen. It has some text and 2 buttons. The top button will increment the counter in the global static class, and then call setState, which will instruct the framework to repaint the screen. Pressing the top button, I will increment the global counter to 4. The second button calls navigatorPush to navigate to the B screen. Here we see the global counter is 4. The B screen has some text and 4 buttons. The B screen includes a local class member variable named localCounter. This localCounter is incremented when we press the Increment localCounter button. I will increment the localCounter to 1. This is the first instance of the B screen. I will also increment the global counter to 5. Now I will press the navigator.push to C screen button to go to the C screen. Here we see the global counter is 5. No surprise here. This C screen has a local counter. I will increment it to 1. This is the first instance of the C screen. Now I will push the Navigator.push button to go to a new instance of the B screen. Here we see the local counter is 0 because this has a new instance of the B screen. It is not the first instance of the B screen. I will increment the local counter to 2 to denote that this is the second instance of the B screen, and press Navigator.push to go to a new instance of the C screen. Here I will increment the local counter to 2 to denote that this is the second instance of the C screen. So now there are a total of 5 screens that are instantiated. The first instance of screens A, B, and C, and the second instance of B and C. We only see the screen C on top of the stack. Now I will press the Navigator.pop button, which will destroy this screen and its data, leaving the screen underneath. Here we find the second instance of the B screen. Pressing the button Navigator.pop destroys this screen, leaving the first instance of the C screen. I will continue pressing the Navigator.pop button until I am back down to the A screen. Now all of the other screens are destroyed and erased. There is no way to get back to them. I'm Chuck Bagby, and I hope you enjoyed the video Static Class State Management with Flutter on DartPad. If you have any contract work, we at OutsourceCoders.com will be happy to help. Thank you.